Let's just make sure you saw everything that you needed to see in the simulation. So you should have, at the end, built this. Two different circuits. The one at the top is parallel. The one at the bottom is series. They each have one battery and three light bulbs with wires connecting them. Let's look at a couple of the differences. In the parallel circuit at the top, look how much brighter all the light bulbs are. That's because the electrons are able to travel from the battery to each light bulb. So it's like we have one loop here getting the full voltage from the battery. It's like we have a different loop from the battery straight to this second light bulb. And then we have almost a third separate loop here. So the cool thing about that is, let's say the circuit gets broken there. Doesn't matter to the others because the electricity can make this loop to the second light bulb or go all the way around this way to the third light bulb. So anytime you add something to the circuit or something on the circuit breaks, the rest of it is not affected. This is why houses and buildings are wired with parallel circuits. There's obviously a lot of advantages there. Let's look at the series circuit. First, I want you to notice the electrons, these little blue dots. Notice how much slower they are flowing. So basically, every time you add another load, another device that uses electricity like this light bulb, it's like they're having to split the voltage from this battery. So the voltage or potential energy in the battery, it's like each light bulb only gets a third of it. So as the electricity comes out, this light bulb uses up some of it. This light bulb uses up more, and by the time it gets to the third light bulb, there's really not much electrical current left. So there's barely any flow of electrons. Notice how the lights are very dim, the little lines here showing they're not very bright. And if I were to break it at any point, like let's say it broke there, notice the whole thing stops because the electricity gets to here and it can't go anywhere. There's no way for it to complete the loop and get back around to the battery. So the disadvantage to a series circuit, well, there's several. One of the main disadvantages is that any problem anywhere on the circuit makes the whole thing stop working. And of course, there's the problem of everything only getting a little bit of electricity. So you get dim light bulbs, or if these were, let's say, speakers, maybe they wouldn't make a very loud sound or just wouldn't even have enough electricity to work at all. Now, when you added this switch, let's say I put a switch. Gotta connect this to my switch. Switch. There we go. Notice how when I close the switch, the electricity can flow. When I open the switch, there's a break in the circuit, so nothing can move. Now, if I were to put a switch on my parallel circuit, I can control one light bulb at a time. So let's try that. I'm going to stick a switch right in here. So I close it and that light bulb works. I open the switch and I can turn off that light bulb. Think about your house. You can probably use a light switch to turn off just one light without turning off the lights in the entire house. So that's another advantage to a parallel circuit. You can have switches that control just one appliance or just maybe appliances in that one plugged into the one electrical outlet without turning on and off every single thing in the entire building.